So this is Laurie, Marion, and I'm Nettrice Gaskins, and our project is Augmented Reality in Open Spaces. This is a project we started actually here in the Augmented Environments Lab here at Georgia Tech. And basically the idea was to do an interactive component of a mural. And we worked with a high school in Oakwood, Georgia with 9th graders with world history. And they did an ancient Roman and ancient Mayan research and mural, and then we embedded augmented reality markers that look like barcodes in them. We figured we could do something bigger, so we proposed to do it for the ISEA conference in Albuquerque, New Mexico. It was last September. So we wanted to do with local youth, high school students, and in a larger way, and more, because we were there once a week, very sporadically, but this would be every day or every other day. So we proposed it, and we did a three-week program. The first week was research, and what's really cool about this project is it merges culture, so local culture and indigenous culture and traditional and ancient culture, and art, contemporary art, and just art production and then mural production, and new media. So the mobile augmented reality piece we did with the high school students here in Georgia, we did again. So for the first week, they learned about ancient members culture. Laurie brought a bunch of books. You want to point that out? Show the pottery.
Yeah, this was members pottery. This was a culture that flourished in New Mexico around 1000 AD. And this is an example of one of the designs. And the students looked at these designs, and they also looked at some contemporary art designs as well as some graffiti. And from that, we asked the students to each create their own image that they wanted to put in the mural. So everybody drew a picture, and then we put them all on a piece of poster board, made a grid over the design, and from that, used the grid to transfer onto a grid that we put on the big wall. This is actually about half the size of the actual mural. And so this was a requirement of the New Mexico State curriculum for geometry. So we were able to align this with the New Mexico State curriculum for math, science, and art education. So the designs were put up there, and so once they drew them, then Nettrice got with the students and painted, and while she was painting, I taught them how to code an Argon channel. Argon is the augmented reality browser that was developed here at Georgia Tech, and it's basically a browser so that what you do to create augmented reality is you code something like a web page. It's basically a web page, and so you use HTML, KML, which is the
same thing Google Earth uses.
It's what Google Earth uses, and so I taught them how to code that, and we used these frame markers, and these frame markers were developed by Qualcomm. It's for vision-based augmented reality, so that what happens when you use the frame markers is augmented reality content appears over the spot where the frame marker is on the screen.
The one thing I'll say about this project is this technology was brand new last year when we used it, and no one had done it quite this way. So we had to do a lot of testing throughout the semester. We had to figure out how to make this work so that you could point a device at it. One thing we did do with the high school students here is we learned how to code it, the content, and we also learned what you do and don't, like lighting issues and things like that had to happen. Now this is outdoors in the desert, so lighting issues, unless it's at night, is not a problem, although maybe too much light in Albuquerque. But we learned that it's also augmented reality technology is developed, it's gone beyond what we were working with just from last year and continues to develop. But we wanted to get a framework or a way in which we can merge this new technology with K-12, in this case STEM type of work, which, because kids use mobile devices a lot. So it's a way to engage them in the process of that. But there's also the STEM piece, which is science, technology, engineering, math, where they actually use software to learn the math principles of our cultural artifacts. So the existing cultural artifacts not only had some relation to them as culture, but also had math principles in them that they didn't even know existed. And so it kind of connected the two things, and science to some degree, in ways that they may never have And these kids are oftentimes dropping out of school. This particular group of students in Albuquerque are really at risk for dropping out of school. So this is a way to figure out how to use all these different things in a way to give them an art experience, but also a way to introduce them to new technology.
And the idea, ultimately, there are two things that I was going to say about the design of the frame markers. If you look here, this is a picture of a santo, this is St. Augustine, and these are painted by Charlie Carrillo, who's a New Mexico artist. But it's part of a tradition. In all the 19 pueblos, there is each one of them has a patron saint. But if you notice that on the sides there are some black and white checkerboard patterns. So it was already part of the sort of cultural grammar of the area to have something like this on the sides of a painting. And the other thing I was going to say about the frame markers is we actually, ultimately what we've done is we've created an information kiosk so that now that the students know how to code an argon channel, they could code other argon channels. They could have something about the football game on Friday night. They could have something about the cool exhibit at the museum. They could write personal notes to each other. There are different ways that you could use this, and so this was a new community information space that we created in addition to the mural that brought some ancient cultures with contemporary designs into their conscious awareness, and something that helped them to express something about themselves and their views of life and death.